Hi everyone! Welcome back to integralcalc.com. Today we're going to be taking the derivative of the function f of x equals ln, or the natural log, of the cube root of x cubed minus x. So this problem is going to be complicated because we've got several layers of chain rule that we're going to need to use. But we'll go through it step by step and we should be okay. So the derivative of f of x is always written as f prime of x, like this, f prime of x. And whenever we're taking the derivative of a natural log, the derivative, the derivative of natural log of x is 1 over x, which means that we've got the natural log of this whole function here, so the derivative of this function will be 1 divided by that whole section right there, everything inside the natural log. Let's first actually convert this. Whenever I'm taking derivatives, or integrals for that matter, and I have cube roots, square roots, things like that, I like to change them. We'll make this ln of x cubed minus x, and I'm going to change this to, instead of the cube root, raise it to the 1/3 power. Remember that like the square root of x is the exact same thing as x to the 1/2, and similarly the cube root of x is x to the 1/3. So I haven't actually changed the function at all. I've just written it in a different way. Instead of writing the cube root of x cubed minus x, I've said the quantity x cubed minus x raised to the 1/3 power, and that's exactly the same thing. But to take the derivative, our first, our outermost layer, remember that with chain rule we kind of start with the outer layer and we work our way in. Well, the outer layer, the outermost layer, is going to be this whole natural log function. The second layer will be everything here inside the brackets, and the third layer will be everything inside the parentheses, right? You can see those 3 layers. So to take the derivative of the natural log function, again going back to this formula here, it will be 1 divided by everything inside the square brackets of the natural log. So it'll be x cubed minus x to the 1/3. Right, so we put that whole thing in the denominator because this formula here tells us that everything inside the natural log function goes here to the denominator. So we've got everything inside our natural log function going there to the denominator. So that is the derivative of the outermost layer, the natural log function. But now we're going to look at everything inside the brackets. Because we don't just have x inside of our natural log, right? This formula here is just looking at ln of x, plain simple whatever. We don't have just ln of x, we have ln of something much more complicated. So we can't just leave it at 1 over x or 1 over whatever was inside our natural log function. We have to then go on to multiply by the derivative of these inner layers, and that's what chain rule tells us that we have to do. So we need to multiply by the derivative of the quantity x cubed minus x to the 1/3 power. So multiplying, right, by the derivative of that is going to be 1/3 times x cubed minus x to the negative 2/3. And the reason for that is because remember that with chain rule, it tells us that we take the derivative of the outside function, leaving the inside function completely untouched, right? So when we took the derivative of the natural log function, we took the derivative basically of ln of x, ignoring everything that was inside, ignoring this whole part here that was inside. We just treated it as if it were ln of x, and we took x and we put that in the denominator, right? Just like we did right here. We ignore that inside function. Chain rule tells us that now we've got to pay attention to that inside function. So we're now paying attention to the quantity x cubed minus x to the 1/3. But we're applying chain rule again because we're ignoring that third and final layer just what's inside the parentheses, x cubed minus x. So we're basically treating this inside function as x to the 1/3 power, right? This is not what we've actually got inside our parentheses. We have x cubed minus x, but we're treating it just like it's a variable. We're ignoring everything inside. So the derivative of this would be 1/3 x to the negative 2/3. And if you see, that's what we've done here. We've got this 1/3 and then x to the negative 2/3. We just ignored x cubed minus x according to chain rule. So that's taking the derivative of the next layer. We brought that exponent out in front, we multiplied it, we subtracted 1 from the exponent to get negative 2/3, and we ignored what was inside. So that is the second layer. But now we have to take the derivative, multiply by the derivative of the third layer, which is x cubed minus x. So the derivative of x cubed minus x is 3x squared minus 1, right? For x cubed minus x, we bring this 3 out in front here and subtract 1 from the exponent, so we would get a 3 here, and this would be 2, so you'd see we get 3x squared, and the derivative of x is just 1, so we get 3x squared minus 1. And we multiplied by that third inside layer, and now that layer is done, which means that finally we have completed our derivative. Now we just need to simplify it as much as possible, and that's a little bit of work too, but here's what it's going to entail. We need to be really careful about what's in our numerator and what's in our denominator. Remember that everything right here is in the numerator of this fraction. So we're going to have, let's get ourselves a big line here. In the denominator, we've got x cubed minus x to the 1/3 power coming from right here. In the numerator, we've got another fraction. This 3 is in our denominator, right? We've got, let's draw another smaller line. That 3 is in our denominator, the 1 is in our numerator. The 3x squared is in the numerator, right? So 3x squared minus 1. Sorry, 3x squared minus 1 is in our numerator. And this x cubed minus x to the negative 2/3 is in the numerator right now, but we would like to change this into a positive exponent. And the way that we do that is by moving it to the denominator of its fraction. If you have, and this is just a rule of algebra, if you have like x to the negative 2 in a numerator, that is the same thing as 1 over x squared. You can move that whole thing to the denominator just by changing the sign on the exponent from a negative to a positive. So instead of x to the negative 2, that is the exact same thing as 1 over x to the positive 2. So in our case, we've got x to the negative 2/3. We can move that to the denominator right here, x cubed minus x, by changing the sign on the exponent from a negative 2/3 to a positive 2/3. So to continue with our simplification, we're going to have 3x squared minus 1 divided by 3 times x cubed minus x to the 2/3 power. And then instead of dividing that whole thing by this term right here, we can multiply by its inverse, which will be a lot easier to look at. So again, I know this is a lot of algebra, but it's another rule from algebra. If you've got, for example, 2/5, this fraction, 2/5 divided by 3, right? Instead of dividing 2/5 by 3, that's the same thing as saying 2/5 times 1 over 3, right? Instead of dividing, we multiply, and all we have to do to multiply instead of divide is flip that 3 upside down. So instead of 3, it's 1/3. So divide by 3 or multiply by 1/3, its inverse. Either way, it's the same thing. So instead of dividing by the quantity x cubed minus x to the 1/3, we can multiply by 1 over x cubed minus x to the 1/3 power. And what this tells us now is that we can drastically simplify. Notice that in our numerators, right? In our numerators, we've got just 3x squared minus 1 times 1. So that's going to be 3x squared minus 1. And then in our denominator, we've got this 3 out in front, which is going to stay. But then we have x cubed minus x. Let me grab a different color. We've got x cubed minus x to the 2/3 power and x cubed minus x to the 1/3 power. Well, we've got the same exact thing inside our parentheses, just different exponents. When that happens, when the bases are the same and they're multiplied together, you can just add the exponents. So because this x cubed minus x is the same as this x cubed minus x, we can add these exponents together. So 2/3 plus 1/3 is 1. So these combine to be x cubed minus x to the 1 power instead of 2/3 and 1/3. We add them together and we get 1. So to simplify, our final answer is f prime of x equals 3x squared minus 1 divided by 3 times x cubed minus x. And that's it. That's our final answer. I hope that video helped you guys, and I will see you in the next one. Bye!